Hey everyone, and welcome back to our Python data analytics series. In this episode, we're going to explore the concept of data cleaning. So data cleaning is the process of fixing data that may or may not be properly formatted, or even removing incorrect entries or improperly formatted entries. The reason we want to do this is simple. It's difficult to do any sort of actual data analysis on a set of data if there are certain rows or fields that are not formatted properly. For example, if we have a data set with 100 entries, and 10 of those entries have NA or null for some of their values, and we try and find the mean of all these particular values, Pandas is going to get confused because we can't find the mean of a range of numbers that don't actually exist. So NA or null values in your data fields are going to cause weird and frustrating errors, so it's important that we fix these issues before we get into our actual data analysis. The dataset we've been using with the AI Global Index may not be the greatest example, partially because this is actually a very clean dataset with no null or NA values in any of the fields. This is probably mostly in part to the fact the dataset is so small, because we only have 62 lines actually in the dataset, but many real datasets that you might encounter will have thousands, hundreds of thousands, or even sometimes millions of rows in them. However, we can still explore data cleaning in the context of replacing and removing singular or multiple entries. We have our imports up here and the code necessary to load our dataset in, so let's get started. Real quick, before we get started with any actual data cleaning, there's one exploration function I missed out on in the last episode that's actually pretty common, so I'm just going to go ahead and cover it here really quickly, and that's what we call the groupby function. Groupby is a helpful function that allows us to group all entries that have the same category variables together. For example, let's say you want to look at all the countries with their income group and group together ones that have the same exact value. We can do this by writing dataset, and then we're calling this groupby method. We'll say .groupby, and then what we need here is to pass in a argument that's by, and then we'll just say income group like that. So basically all we're doing here is specifying our dataset, calling the groupby function from Pandas, and then this function needs one argument, the by argument, and then we're just setting it equal to our income group. However, if we run this, you'll notice that nothing actually displays here. So when we're using groupby, you have to do some operation after grouping it to actually get a display. So if we wanted to use our describe function from the last episode, we could just add .describe here like this. And now if we run it, see, okay, it prints out, and we'll only have 3 rows, one for each possible category variable. We have high, lower middle, and upper middle. And each one has stats for each particular field. So there's the talent field, and it has, the same thing we had in the describe table. We have count, mean, standard deviation, and so forth. And there actually is some overflow here. And then if you look at, like, say, a total score, you can see the same thing. And it basically just groups it per each categorical variable. If, for instance, I wanted to grab the mean values of each income group, I could replace this .describe here with .mean instead. And if I run it, it will give us the average value of each variable within each grouping. So, for example, countries with a high income group have an average talent number of 20.33, and let's say countries that have a lower middle income group have an average research value of 3.21. So this is super useful for partitioning categorical variables to draw some conclusions, and we're going to actually explore this groupby function a lot more in a future episode as well. And this is also the first instance we've seen of what's called method chaining. So when we call methods on Pandas data frames, we can just write one method after another using the dot operator. What I mean by that is up here I have dataset.groupby.mean. And if I wanted to add more, I could do like something like .head like this, and then after that I could do like .filter and so forth. It does each method sequentially, so you don't need to worry about having a line for each individual method. You can lump it all into one if you want. But for now, I'll just go ahead and delete this just so we have it back at the mean. There may come times where you need to replace pieces of data in your dataset. Maybe the values you have currently are formatted in a bad way. Maybe they are extremely long strings that need to be shortened, or maybe they are just misinputs that are simply incorrect. Whatever the case may be, replacing data in a dataset is an essential skill to know. But before we replace any data, I made a point in the previous episode that you should never pollute the original dataset. So to follow this point, let's actually go over dataset copying really quick. So I'm going to actually make a copy of dataset. I'm going to call this one mod data. And then to make a copy of a dataset, we should just type the name of the dataset that we want to copy. So we'll do dataset and then .copy like this. So we're just calling a copy method. And if I actually don't write this copy, it'll basically just create an alias for the original dataset, which means if we edit the mod data, it'll actually edit this dataset too as well, which we don't want. We don't need to make a copy of the dataset each time we want to change something. We just want to make sure at the beginning we make a copy, and then we can edit this copy kind of however we want. So I'll go ahead and just run this here so it's copied, and now we're good to go. The first thing we want to look at for data replacement is a simple replacement of a single value in a dataset. In our last episode, we explored the lock and ilock functions, and those functions are extremely helpful when it comes to data cleaning. Hence why I went over them in the last episode. Let's apply them in this episode though. Let's say, for instance, we want to change the value of the United States research. Obviously, we don't want to just randomly be changing data for no reason, but let's assume theoretically this number is faulty for whatever reason there may be. So to do this, we can use the lock function to select it, and then use an equal sign to change it. To show you what I mean, let's type it out. So I'm going to go into this cell here, and I'll type it out just like this. So like I said, we're going to use the lock function to select, so I'm going to do .lock, and the United States is at index 0, so I'll select the first row, which is 0, and then the research column. And then all I need to do to change the value is set it equal to something else. So I can say equals 50. So basically all we're doing is selecting the value we want to change and setting equal to something else. If we actually print this off now, or sorry, I'll go ahead and just print like this. I'll print this off. And then now if we run it, if we look at the value of research for the US, it is now 50 instead of its default value of 100. So just so I don't actually mess up this data set, I'm going to change this back to 100, but you get the picture. Actually, for instance, real quick, show you something else, like 75, that's changed here. We can do like any number really, and it'll be replaced with that value. But I'll change it back to 100 here, just for the sake of consistency. So this way of data replacement can be useful from time to time, but if we have many entries that need to be changed, typing the log function just for individual entries and changing them all manually is going to take an unreasonable amount of time and it'll be super inefficient. So luckily we have a solution for that. So the first function we're going to use is simply just called the replace function. And like most of our other functions, it comes from pandas. The replace function works like this. It takes in two values. The first value is the one you want to replace, and the second value is the one you want to replace it with. So it seems simple enough. Let's get into it. So let's say for whatever reason, we look at our data set here, and we see that this is titled Asia Pacific for all the countries in the Asian continent. So instead, we just want to have it say Asia because that's more readable and easier to type out. So to do this, let's actually go into our multiple data replacement cell here, and I'm going to call our mod data dataset, and then I'm going to call this replace function on it. And then let's just pass in two values. So like I said, value 1 is the value I want it to be replaced, which is Asia Pacific. So I'll just type Asia Pacific. And then we want to make sure this type exactly how it appears. And then value 2 is the one you want to replace it with, which is just Asia. Now let's go ahead and just print the head of this real quick. And we'll actually notice something interesting here. If you look at this, you'll notice that it actually didn't change. It is still Asia Pacific. So why is this? So there's actually a third argument we can pass into this function that specifies whether to actually modify the dataset or not. And we call this the inplace argument. And by default, it is always false. And this argument here you're going to see is appearing in a lot of different functions that are kind of like modifying and mutating data. So this is useful to know just in general. So basically, if we want to change this and we want to actually modify the dataset, we can actually explicitly state that. So we can add this inplace argument here. We can say inplace, and then we can set it equal to true. And then if this is the case, now when we run it, you'll see that it actually does change Asia Pacific to Asia. So really what this inplace argument comes down to is if you want to modify the dataset you're actually working with directly, use inplace equals true. Otherwise, if you're making a copy of it and doing something else with it, ignore this argument and it'll default to false. I would just advise you never use inplace true on the original dataset to not pollute the data. However, since we have this copy dataset here, it should be fine. One quick upgrade we can make to this line is select just the region column. Because we didn't select any specific chunk of data, this line of code right here is basically going to look over the entire data set for anywhere that it says Asia Pacific. The only place we're ever going to see that is in the region column. So I'm just going to go ahead and add a square bracket here like this, and I'm just going to type in region. This is a bit of an optimization thing as it will help your function to run a little bit faster if there are many lines of code, because basically we're just selecting the region column instead of selecting the entire data set. It's always good to be as specific as possible when you're editing data. So let's just go ahead and run it, and obviously it'll be the same result. So next up, what if we get a really large data set and we decide we don't want to deal with some of the variables? Maybe when researching, we only want to look at a couple of the variables and ignore the others. If we wanted to get rid of some of the variables, meaning some of the columns, one option is to do what we did in the last episode, which is use square brackets to specify which columns you want. However, what if you have 100 columns and you only want to delete one of them? You don't want to have to specify the 99 you want, rather you should be able to specify the one you wish to delete, and I'll show you how to do just that. And for dropping columns, Pandas has a really nice function for this called the drop function. You can actually use this function to practically drop anything from the dataset, but for now we're just going to look at dropping a particular column or multiple if we want to. So it's actually pretty self-explanatory how we use this drop function. So we're going to go in this cell here, we're going to type the name of our dataset, so mod data, and we're just going to call the drop method on it. There's many potential different arguments you could pass in here. However, we want to type columns and then equals, and then type whatever column we want to remove as a string. If we go up here and look at our dataset, the most important pieces of data are going to be these numbers that we have. So for example, fields like talent, infrastructure, operating environment, and so forth. Let's say, for instance, however, we don't really care about the categorical variables like region, cluster, income group, and political regime. So let's just say for right now, we just want to remove this cluster column. To do that, in our drop function, we would just type the string name of the column. So we would just type cluster like this. And then, just like last time, we'll add our inplace argument to actually modify this mod data dataset. So we'll say inplace equals true. And then I'm just going to go ahead and print the head off here like this. And then if we run this now, you'll see there's no longer any cluster column because we completely dropped it from the dataset. What if I instead just want to remove not just one column, but multiple columns? If this is the case, we can just pass in a list to our columns argument instead of a single string. So to do this, we can just add square brackets to our argument here. So we would do something like this. And then we can pass in, not squiggly brackets, square brackets. And then we can just pass in multiple column titles as strings separated by commas. And just for the sake of showing you how this works, let's just delete all the categorical or non-numerical data points. So let's just delete region, cluster, income group, and political regime. So in here, we'll say region, comma, cluster, and then have income group. And then lastly, we have political regime like this. And one thing we want to make sure of is that the uppercase and lowercase matches exactly what the titles are here, because Pandas is case sensitive and won't recognize the terms if the uppercase and lowercase don't actually line up. So now, if we go ahead and just run this, let's see, we get an error here. It says cluster is not found on access. Oh, okay. So we already deleted cluster, so it's actually giving us an error here. So we can actually just delete that like this, and then print it off, and you'll see that now all region, income group, political regime, and the cluster columns are all gone. And we're actually going to be using these categorical variables later on in the episode, so I'm actually going to go up here, and I'm just going to recopy the mod data just so we can get a new fresh one without the things being deleted, just because we want to use them a little bit later. Sometimes, however, the case may actually arise in your work where you do have columns that are actually just useless to you and just take up space, in which case is a very easy way to delete them. For our very next scenario, let's say we have a scenario where the title of a column is way too long, or maybe just not very descriptive of the data. Well, we have a way to rename column titles that's actually pretty straightforward. Let's say you want to make a new data set where we've renamed the total score column to just total. Here's how we would do it. So to do that, in this block here, I will just type mod data.rename. And then inside of this, we need to specify a columns argument. So I'm going to say columns equals like this. And now, according to Pandas documentation, this columns argument has to be a dictionary, where each key is the old column name and each value is the new column name. So to denote a dictionary, we would use squiggly brackets, and then let's change the name. So again, let's just say we want to change the total score column title to just total instead. So because total score is the actual current name, let's type total score like this. And then as the corresponding value pair, we'll just type colon and then total, because that's what we want it to be renamed to. Let's actually make this a new data frame because I don't actually want to modify this data set just yet. So I'm setting this all equal to a variable called testing. Let's just make one, let's say testing.head. And then if we run this now and we look here, it is no longer total score, it is just total. So we've successfully renamed the column title. What if we want to rename multiple columns? For that, we could just add values to our dictionary separated by commas. So let's say for whatever reason, we want to take this government strategy here and just turn it into govstrat. To do that, we can just add a comma here in our dictionary. We just add it right here. And then we could add something like this. We can say government strategy. And then again, this needs to be a key value pair. So for our second value here, we'll just say govstrat. And then now if we run it, the total score has been renamed to total, and then government strategy has been renamed to govstrat. So our next useful function in Pandas used in cleaning is the dropna method. It's similar to the drop function, however, rather than taking in arguments for specific rows or columns, what it does is delete every row or every column that has an NA somewhere in it, meaning not applicable or null. So NAs often appear when there are errors in the dataset or if certain fields cannot be calculated or shown based on what the data is trying to represent. As you can see from this dataset, we don't actually have any NAs anywhere, and I've looked over it just to double check. However, it is fairly common to see them in the world of data analytics. However, if I did want to delete any rows that have any NA values anywhere in them, I could simply just type something like this. I could do mod data, I could type drop NA, and it's as simple as that. So by default, this right here will drop all rows with NAs in them. If, however, we wanted to drop columns with NA in them, we could just put 1 in here, and that is actually the value that would signify columns. So 0 is a number that signifies rows, but it actually defaults this, so we don't need to actually explicitly say 0, and then 1 would identify columns that need to be deleted. I would, however, just caution against using the dropna function freely though, because sometimes the NA is actually there for a good reason and it makes sense why it's there. So just simply deleting rows outright may skew the data and may not be the very best option for handling this. An alternative option to using this could be the fillna function. So fillna just specifies a value to fill NA values with, rather than deleting the rows altogether. This can help to maintain the accuracy of the original dataset. However, we should be careful about what we fill the NA with, as filling it incorrectly could impact our analysis. To fill all NA values within something, we want to call the fillna method on our dataset. So let's just type moddata.fillna like this. And then all we need to do is basically pass in the value we want to replace it with. So there's a couple of different ways to fill these depending on what your dataset is. However, one common method is to simply fill NAs with 0 if the field is typically numerical. So to do this, all we would need to do is type 0 in here, and it would fill all NA values with just 0. And just like many of our other functions, there is an inplace argument for this one as well to make sure you modify this dataset. So I'll just go ahead and run inplace.true, and then I'll just print off head here. And then if we actually just run this, nothing actually happens to our datasets since we don't have any NA values. But if we did, they would all be filled with the value 0 since we specified it right here in the fillna method. It's also possible to only select certain columns or rows when we're doing this. So we can use what we learned with lock and ilock last episode to make this easier. So for example, let's say we wanted to fill only the NA values in the columns that have numerical values, which are just talent all the way through commercial. So basically here, all the way through this column here. It wouldn't make sense to replace categorical variables with 0 since a number doesn't make sense for values that typically have words in them. Like for instance, let's just say we took the income group column. It wouldn't make sense to fill an NA here with 0. So let's just go ahead and look at the numerical columns first. Let's look at only talent through commercial and how to replace these just individually. So to do that, all I'm actually going to do in here is just instead of calling in the whole data set, I'm actually going to make a .lock function. So I'm going to say .lock with our square brackets as we normally do. And then I'm going to put a colon here, like I showed last episode, to select every single row. And then I just want to type talent all the way through commercial like this. And then we're keeping this same fillna, and we're filling in one with 0, and then inplace should be true, so we modified this actual data set. So all this line is doing is selecting every single row with this colon here that has a numerical value, so everywhere from talent to commercial. And then it is calling the fillna function to fill them with zeros if there are any NAs in there. And again, we don't have any NAs if we actually did this, so it wouldn't actually do anything when we run it, but this would be one way to do it. And then if we look at our categorical variables like region, cluster, income group, and political regime, it would likely make more sense to fill those NA values with something other than a number. Maybe we want to replace it with the string unknown, for instance. So to do this, we can do a really similar thing to what we did in this line. And instead of selecting talent through commercial, let's actually just select, we'll say region, all the way through political, should I spell that right? Yeah, political regime. And then we would do the same thing, except instead of having 0 here, let's just fill it in with the string unknown. And then basically all we're doing here is using lock to select all the rows in the moddata dataset, and then all the columns between the region and political regimes, and then filling any NA values with the string unknown. And again, just like before, it won't actually do anything because there's no actually NA values in here. But if there were, it would fill all of these columns here and the rows with the value unknown if it found any NAs. Next, let's look at another example of data replacement that may be super useful for you in the future. So let's say we just look at our data set and we look at these decimal values here. We say, I don't really like that these numerical values are decimals. Rather, I'd rather have them to be integer values or whole numbers instead. So how can we change the type of all these variables? Pandas has a nice function for this known as type. Whatever we do, we want to make sure we're not selecting the whole data set. So let's go down here into our changing value type cell. I'm going to do a lock statement. I'm going to say moddata.lock and then square brackets as usual, colon to select every single row. And then we're going to select everything from talent to commercial, or basically all columns from talent to commercial. And then normally if I was using something like replace or fillna or anything along those lines, I could just type dot and then the function name, and then I could just do inplace true like that to modify it originally. However, this asType function doesn't actually support the inplace argument, so I'm actually going to have to do these manually. So I'm going to go ahead and just leave this here. However, there actually is a pretty easy workaround to doing this. What we're going to do is basically just copy this here. We're going to make an equal sign, and then we're going to paste it on the other side. Then on this other side here, we're just going to type dot as type, so we call that method, and then convert to an int. So basically what this line is saying is that all rows and columns between talent and commercial are now equal to the same exact thing, but just changed to integers using the asType method. So now if I were to just go down here and type moddata.head like that, and I ran it, you would see that there are now no decimal values. They're all integer values between talent and commercial. One thing you notice when you're converting from int to a decimal number, or a float, I should say, is that it'll simply just drop the decimal. So for instance, Canada, we have 31.28 for talent. When you convert to int, it basically just rounds down since it drops it, and this basically 0.28 just goes away. So now we just have 31 for our talent value. One more thing you want to potentially look out for with your datasets is the idea of duplicate entries. So duplicates are entries that are perfectly identical, and they're important to detect because in some contexts, duplicates, whether on purpose or an accident, could theoretically skew your dataset in a negative way. Obviously, duplicates aren't always bad depending on the context you're working within, but sometimes they can be, so let's actually look at a way so we can remove duplicates within our dataset. A super easy Pandas function to use for this is simply the drop duplicates function. This function will examine every single row in the dataset, and if there are any rows that have the exact same values for every single variable, then it will identify those rows as duplicate rows and it will delete them. And to call it is actually very simple. All we need to do with that is call our dataset, so let's say my data drop underscore duplicates, and then we're going to do our inplace equals true here. Every row in our dataset is unique to an individual country, so there's no duplicates in our dataset. However, if we were to run this and there were any duplicate entries, they would be removed. So let's just go ahead and run my data.head. Obviously, there aren't any duplicates here, but if there were, they would be removed. Okay, the very next thing I want to do is show you how to make new columns based on existing ones. So I'm actually going to make a new code block here. I'll just have a comment. I'll just say make new columns. So a lot of times when you're looking at data, or when you just hear the term in general, you talk about research and development. And a lot of times they're kind of grouped together as one thing when it's just called R&D. So let's say we want to make a new column for each country where we just take the average out of their research and development values and just score it to get our own individual R&D column. To do this, we would go down here. We could type something like this and just follow along. So I'll type mod data, and then I'm going to do square brackets here to select, and I'm going to make a new column. I'll say R&D average. I'm going to set it equal to the average of the other two columns. So I'll say mod data, and I'll grab research. And then we want to add them together. So I'll do mod data development. And then, let's see. And then, okay. And then we want to divide them by 2, just like this. So by using square brackets on a column that doesn't actually exist, like R&D average, it'll make a new one if you use an equal sign with it. And here we're just setting equal to the average of research and development, hence why we're adding them together and then dividing it by 2. So now if we just make a mod data.head here and then run this, you'll see it actually did make an R&D column, but it made it at the very end here, but it did appear to work. But it's kind of inconvenient for the ordering here that the R&D average is at the very end because it's after all the categorical variables and not right after research and development. So let's actually make a new code block down here, and let's just say rearranging columns, and we'll explore that right here. So to do this, we can actually use the pandas insert function. So to use it, we'll just type something like mod data.inserts like this, and then we're going to pass in some arguments here. The first argument needs to be the index you want to insert out. So let's count over the indexes of the columns. So we have 0, 1, 2, 3, 4, 5. So it looks like development is at index 5. So if we want R&D average to be right after that, we need that to be at index 6. So let's go in our insert function here and just put 6. And then what's the name of the column that we actually want to move? So let's just enter that as a string. We want to move the column titled R&D average. And then we need one final argument here. If we run it just like this, it'll actually work. However, we'll still have our R&D average at the very end of our data set, so we'll actually have 2 R&D average columns. So we want to remove the existing one. So to do that, we're just going to type mod data.pop and then pass in the name of the column like this. And this little function here as a third argument will actually remove the duplicate. So now we should be good to go. So let's actually just type mod data.head like this and then run it. And now you'll see we nicely have our R&D average score right after development instead of at the very end. So it's now been rearranged to a more correct location. So now you should have a good idea of how to actually just rearrange a simple column like that. I hope you were able to learn quite a bit in this video. In this video, we went over single data replacement, multiple data replacement, dropping and filling NA values, renaming columns, changing the type of single and multiple pieces of data, dropping duplicates, and adding and rearranging columns, as well as just using lock to generally help us select data that needs to be cleaned. Now that we have a solid understanding of exploration and cleaning, in the very next episode, we're actually going to move forward into what's called data visualization. So I'll go ahead and see you in the next one.